Okay, so we are starting off in 1.4, which is solving equations, which you should have done in Algebra 1, and honestly in pre-algebra, 7th, 8th grade math, you've done this for a while. So we're going to solve some equations here. I'm going to break this lesson up into two parts. Just starting off with solving equations. So what is an equation? It's a statement that two expressions are equal. There's an equal sign. Basically, that's what makes it an equation. And the equal sign is a very strong symbol. It means whatever's on one side is absolutely equal to the other side. So it doesn't mean they look the same. It means that they are equal. So again, a $20 bill is the same thing as two tens. They're equal, but they certainly aren't the same. So to solve, we're going to use inverse operations, which are just operations that undo each other. So the inverse of addition is subtraction, the inverse of subtraction is addition, and inverse of multiplication is division, so on and so forth. So we'll talk about those as we go through. So I'm going to put this here, the 6 steps that I consider. These are not in any specific order other than like 3 and 4 you can do, or 2 and 3 you can do at any time, doesn't matter. But this is just, if you get stuck, follow these steps. Number 1, if there's parentheses and you can distribute, you should distribute. We're going to combine like terms on the same side, which means if you have a variable on one side of the equation and it's added or subtracted to another variable, you're just going to combine them. Same thing if you have two numbers on one side. So you're going to add those. Okay, and then we'll move the numbers to the opposite side that we moved the variable to. We're going to multiply or divide by the coefficient. Then we can always check our answer. So let's take a look at some examples here. So I'm going to start off with a simple 2-step equation here, which is 7x plus 6 is equal to 41. So as I can see, the x is already over here on the left. I'm going to subtract 6 from both sides because the inverse of plus 6 is minus 6. So this plus 6 and minus 6 would cancel. Leaves me with a 7x is equal to 41 minus 6 is 35. Now this reads mathematically 7 times x equals 35. I'm going to divide both sides by 7. And that would give me x is equal to 5. Again, we can always go back in, check the answer. 7 times 5 is 35. 35 plus 6 is 41. 41 equals 41. So we'll get into a little bit more challenging of a problem here where we see parentheses. So again, we're going to distribute here, okay, to get rid of the parentheses. So that would be my step 1. So I have 15 minus 20x is equal to 7. Here I'm distributing a negative 1. So negative 1 times 4 is minus 4. Negative 1 times negative 1x is plus x. So now I look at step 2, and this is where I have to pay attention. I can't combine this 15 and minus 20x because they're not like terms. But over here, I've got this 7 minus 4. Those are like terms. I literally just do what it says. It's not inverse operations. So I'm going to leave the left side alone, and the right side it's going to become 3 plus x. Now I get the x's on one side. So I'm going to, doesn't matter which way, but I'm just going to move this minus 20x to the right. I'm going to add 20x to both sides. That will leave me with 15 is equal to 3 plus 21x. I'm going to subtract 3 from both sides. That gives me 12 is equal to 21x. Divide by 21. Okay, that gives me 12 over 21 is equal to x, which if I reduce that, they're both divisible by 3, would be 4 over 7 is equal to x. Again, you can go back and you can plug that in to get your answer there. So again, following the steps that I put over here on this slide, is the first thing I did was distribute, then I combined like terms. I decided to move the variable to the right. Doesn't matter which side you move it to. Then I moved the opposite numbers, and then I divided by the coefficient there to get 4 over 7. And again, you could go and plug this in, and you could check that both sides do equal the same number there. Okay, just make sure you pay attention to your signs. Right here, when I multiplied 5 times negative 4x, that's a negative 20x. Okay, when I multiplied negative 1 times positive 4, it's a negative 4. Negative times a negative is a positive. And then here I'm doing inverse operations. So you can always go back and check your answers. So now, solving a multi-step equation with infinite answers. I'm going to do the same exact thing, follow the same steps. Something different happens here. Okay, so when I combine like terms, there's no parentheses to distribute. So when I combine like terms, 6x minus 2x is 4x. plus 5 is equal to, here I can combine the 4 and the 1, which would give me 5 plus 4x. So now I'm going to move the x's to both sides. Okay, I'm going to choose to move this 4x to the other side and take a look at what happens. I've got 5 is equal to 5. When the variables cancel, they canceled on both sides. There's no variable left. If I'm left with a true statement, does 5 equal 5? Yes, it does. Then that means that there is infinite answers. No matter what I plug into the left, it's going to equal the right-hand side. Okay, so again, don't do anything different mathematically, just something different happens when you do the math. You have to make sure that you pay attention to that, because if your variables cancel, then that means that there's infinite solutions. So now, same exact thing. Okay, here I can combine the 11 minus 7 would give me 4 plus 3x is equal to 6 minus 3x. You notice I'm not doing 6x plus 5 because they're not like terms. Like terms are 6x minus 3x would give me a 3x plus 5. I'm going to move the variables, so I'm going to subtract 3x, and you'll notice they both cancel here. And it leaves me with 4 is equal to 5. Does 4 equal 5? No, this is false. Okay, it's a false statement, which means there is no solution. So the answer to this is not false, it's no solution. So there's the examples. I'm going to give you a Delta Math assignment to work on some solving equations. Again, it should be a lot of review. I hope it's a lot of review, but we will